So let's take a look at this homework, this graphing and features of functions homework. So remember, we eliminated some of these, so we only need to do 1, 2, 4, 5, 6, and 7. So first you need to graph them. My suggestion, use some sort of graphing app, because you can graph them by hand, but that's not the important part. The important part is understanding what's going on. So let's take a look at our first graph. So here's our first graph. Okay, so this is number 1. Okay, it's absolute value, obviously. So looking at this, okay, it's not intercepts. So here's our x-intercepts and our y-intercepts, right? So you just write them as the points, -7, 0, 13, 0, and so on, okay? Now, so that's our intercepts. We graphed it, we have our intercepts, maximums and minimums. There's no maximums here, but we do have a minimum. Right here, right, the lowest point, 3, -5. Okay, when is this increasing or decreasing? Well, so we start out here at -infinity, it's decreasing till we get to x value of 3. So remember, we write that as -infinity to +3. And then that was actually decreasing. Increasing would start at 3 and go out to +infinity. Okay? Now, where's this negative? From here to here is where it starts being negative, right? So from -7 to +13 is when the graph is under a negative. When is it positive? Well, it starts out at -infinity till it gets to -7. And then it jumps and starts again from 13 to +infinity, because it'll just keep being positive over here. Okay, now our end behavior. Symmetry. Okay, does it have symmetry? Yeah, if we drew a line right here, it would be symmetrical over that line, x equals 3, that vertical line, so you could talk about that. But end behavior. So, as x approaches -infinity, as we go to the left, which way are we going? Where's f of x approaching? It's approaching up, so it's approaching +infinity. Same with here on the right, right? As we go to +infinity, we are approaching +infinity. Okay? And there's our first one. All right. So let's get rid of this graph. Did that one. So let's take a look now at number 2. So here's our second graph. Okay. We have no minimums. You can see that maximum, right? 0, 4. A y-intercept that's also 0, 4 for our y-intercept. Our zeros, our x-intercepts, right there and there, right? Positive and negative, 1.414, 0. Okay. And like we said, no minimums. Whereas are we increasing and decreasing? Well, we are increasing. As we go over here to the left, we're going to keep going up until we get to that maximum. So from -infinity till we get to 0. So it's decreasing from 0 to +infinity. The right side, it's going down as we go across this way, starting at that 0. Okay. Positive and negative, we're positive from that point to that point. So from -1.414 to +1.414. So we're negative from -infinity, right? Because as we keep going right here, as we keep going to the left, we're going to be negative. Just as we keep going to the right, we're negative. So -infinity to -1.414. And that U for union, because we have to jump a spot, 1.414 to +infinity. Okay, is it symmetrical? Yeah, over the y-axis. End behavior? Well, as x approaches infinity, +infinity to the right, f of x approaches, it's going down, right? It's a negative quadratic, so we know that they're both going down. So as it approaches -infinity, it's also going down. Okay, the one thing we don't have on here that we could also talk about is domain and range. Okay, domain is all the possible x values, right? So if I go on this x-axis and go up or down, will I eventually run into my graph? And we keep going to the left and to the right, so domain would be negative infinity to positive infinity. Range, however, we don't go above this 4, right? We keep going down to negative infinity, so range would be negative infinity to 4. So let's take a look at question number 4 now, because we skipped 3. Okay, so now on this one we've got positive cubic, so we know that for our end behavior, as x approaches positive infinity, f of x is also approaching positive infinity, and as x approaches negative infinity, as we go to the left, f of x is approaching negative infinity. Okay, we can see we've got 3, which that degree of 3 would tell us 3 x-intercepts, 3 zeros, 3 roots, right? That fundamental theorem of algebra tells us that. We also have 1 y-intercept right here. Okay, we've got a relative maximum here. This is x, 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 y. And we've got a relative minimum here. Okay, so you write those ones right here as points. Okay, so positive and negative and symmetry. We would, to find the symmetry, it would be like a rotational symmetry about this point in the middle here. Okay, when you could rotate it and have it have that symmetry. So if you put rotational symmetry, that's fine. If you leave symmetry off, that's fine. Domain and range. Okay, we're to the right and to the left. This will just keep going. So negative infinity to infinity. Same with range. It keeps going up, keeps going down. Negative to positive infinity. So the only thing to talk about is looking at positive and negative. Positive from here to here. Up here, how do we write that for positive? Well, from negative 3 to negative 1, union, because it jumps. Then from 3 to positive infinity. And for negative, the bottom sections, it goes from negative infinity to negative 3, then jumps to negative 1 and 3. Okay, notice together we have our domain and our range, right? Okay, the last one, increasing and decreasing. Well, it increases right here, right? So from negative infinity to negative 2.097. And then it jumps down here and starts increasing again. So from 1.43 to negative 16.9. Oh, whoa, it's totally off. To positive infinity. I don't know what I was thinking there. Just doing that minimum. So it's decreasing in that section from negative 2.097 to 1.431. Okay, increasing, decreasing. Alrighty. Let's keep on trucking. By the way, all of these graphs are possible because of Desmos.com. You know, when we're dealing with stuff where we want to know what's going on with the graph, I would prefer that you just go there, graph it, sketch the graph, use those points, help yourself out. So you're not just wasting all your time on trying to figure out the graph. Okay, let's do number 5. Okay, so number 5, we're dealing with this square root. It's a negative square root, so we moved it down. Okay, it's a negative on the inside, so it reflected over the x and the y-axis. And we moved it to the right 5 and up 2. So a maximum here at 5, 2. There is no minimum. Okay, that's also going to affect our domain and range, right? Because our domain won't go beyond that 5, but it'll keep going to the left. So domain would be negative infinity to positive 5. Range would be, it keeps going down until it gets up to 2, would be from negative infinity up to 2. That would be our domain and range. 1 x-intercept, a 4.5560. 1 y-intercept at 0, negative 4.708. Okay, and it's always increasing, right? So the increasing would be the same as the domain. And decreasing doesn't happen. Okay, our end behavior. Well, let's do positive and negative first. Okay, it's only positive from here to here, right? So positive would be from 5, I'm writing them backwards, aren't I? 4.556 to 5. So negative would be from negative infinity to that 4.556. Okay, are we getting them all? Yeah, end behavior symmetry, there is no symmetry because there's no way that we can get this to work. So, end behavior. As x approaches infinity, f of x approaches, and as x approaches negative infinity, f of x approaches. So as we go to the right, we approach that y value of 2. As we go to the left, we keep going down, 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 we approach negative infinity. Alright, done with that one. So 2 more to hit on this page. So 7 and 8. And by 7 and 8, I actually meant 6 and 7. That's what we meant to say here. Okay, so 6 is that e. Remember, e is like 2.7. Or no, 1.7. So it's an exponential graph. And we moved it, we shifted it to the left 4 and down 3. Okay, so actually that should be 0, negative 3. Because at negative 3, this line isn't going to get below negative 3. Okay, that's kind of the barrier. So as we look at end behavior, as x approaches negative infinity, f of x is going to approach negative 3. Okay, it's going to get as close as it can to this line, but it's never going to touch it. As we go to the right, as x approaches positive infinity, we're going up and up, so we're positive infinity again. Okay, once again, there is no symmetry. Okay, as we go left to right, it's always increasing, never decreasing. So increasing from negative infinity to positive infinity. Okay, domain and range. Our domain keeps going left, keeps going right. Negative infinity to positive infinity. Our range, however, doesn't go below that negative 3. So it would be negative 3 to infinity. We have one x-intercept right there. One y-intercept right there. Okay, positive and negative. It's negative from negative infinity to that point, negative 2.9. And then it's positive from that point to negative 2.9 to positive infinity. So I think we got all those ones. Alright, last one on this part. Now we can take a look at number 7. And notice it's natural log, the inverse of 6. So it'll look like that, only rotated, reflected across that. So here we go. A couple things to note here. Okay, end behavior as x approaches negative infinity, f of x approaches, and as x approaches positive infinity, f of x approaches. So as we go to the left, we're going to approach this asymptote. It's never going to, as it keeps going down, it's going to get as close as it can to that line 3, but it's never going to get to it. But it is going to keep going down. So it's approaching that 3, but it keeps going down to negative infinity. That one's kind of a weird one to understand. As we go to the right, we're approaching positive infinity, keep going up. X-intercept here, no y-intercept because we never get past that line. Okay, our domain, we're never going past that line 3, so it's from 3 to infinity because we keep going to the right. Range, even though we go really slow, we go all the way to negative infinity, all the way up to positive infinity. Okay, it's always increasing again, never decreasing, so from increasing from 3 to infinity. Same as the domain, never decreasing. We've got just our positive and negative max and mins. We don't have max and mins, which that was the last one. The last one we didn't have on the exponential either. So positive to negative, well, that x-intercepts the barrier. So from 3 to 5.718, we are negative. From 5.718 to infinity, we are positive. So, there you go with those guys. I hope you tried to graph those on your own and do that on your own first. See how you did. Now let's jump to the second part where we're actually drawing. Now this Desmos isn't going to help you. This you got to be able to do on your own. Now looking at that second page, now we're drawing those graphs. So, f of x is an even function that decreases at a constant rate from negative infinity to 0, has a minimum at 0, negative 3, and a point at 2, 0. So let's start off with those, a few of those pieces that are easy to see. A minimum, 0, negative 3. Okay, that's also the y-intercept. It's a minimum, so I know my graph is going to be going up from there. Also have a point 2, 0. Okay, an x-intercept. So I know we're hitting up there. Now it says it's even, okay, so our end behavior is going to be going up on both sides because it's even. And since this is a minimum, it's not going to go below that. So, and it decreases at a constant rate from negative infinity to 0. So from clear out here till we get to 0 right here, it's decreasing at a constant rate. The only things that have that constant rate, okay, would be, well, suppose that, when I think of constant rate, I think of a line, because that slope is constant. Okay, whereas anything else, the slope is going to be different. So the way I would interpret that into meaning would be that it starts up here, and as we get to 0, we decrease to there in a straight line. More like, I would probably draw this more like an absolute value graph. Alright, number 2. So it would look like that anyway. And yours may not look exactly like this, but that's the point where we're not getting specific as long as we are following those rules in our question. So now number 2 says it's periodic. Periodic means that it just repeats itself over and over and over. Okay? An odd function that has x-intercepts at 0, 0, and then plus or minus 4k, 0. What that means is every 4 points in the positive or the negative, we have another x-intercept. So it's just going to keep repeating itself every 4 places. It's got a maximum at 2, 3, so 2 up 3, and a minimum at 6, negative 3. Okay, so this is what we would call one period. Okay, so it's going to just repeat that over and over. So I'd have to keep drawing maximums and minimums the same amount of space. So it's just going to repeat itself like this. That's what the periodic means. This would be like one period, and then we just keep repeating. This would be like one period, and then we just keep repeating that over and over and over, going either way. Alright. Okay, 3 and 4. So 3 says h of x is a function with a maximum value at 1, 9. So 1 and up 9. Intercepts at negative 2, 0. And 4, 0. And the end behavior, remember this is just a different way of writing it, that limit as x approaches infinity is the same as x approaches infinity. That h of x equals negative infinity is the h of x approaches negative infinity. So as we go to the right, it's going down. And as we go to the left, it's also going down. Okay? So, probably looks something like this. Kind of a parabola shape. Because we've only got those two x-intercepts, I know the end behavior is going down, and I know I've got a maximum up here. Number 4, j of x is a function with intercepts, I don't know what that's for, at negative 1, 0, and 0, 3. So it's got x and y intercepts. The end behavior, as x approaches negative 2 from the right side, that's what this is. This is getting pretty crazy here. So as we approach this line right here of negative 2, and we're coming from the right side, not from the left side, that's what the plus means, then we're going down. So this is going to be going down. And as we approach positive infinity, we're going up. So it's kind of like, passes through the 0.37. Okay, so it's that logarithmic style, like that. Alright, 5 and 6. 5, f of x is a function that increases negative infinity to positive infinity, so it's always increasing, with intercepts at 4, 0, and 0, negative 6. And behavior, as we go to the right, it's going positive. As we go to the left, it's approaching negative 9. So negative 9 would be right here. Okay, it's always increasing, so because it's never going to get past this line, it's not going down, so it's going to probably look more exponential. And then it'll shoot up, hit that, and then just keep going up. That way it's always increasing, like it said. We're hitting those 2 points, and we're never going below here. If I would shoot this down here, it wouldn't have that same limit. So that's what it looked like. Okay, number 6. G of x is an even function with a minimum negative 2, negative 5. So minimum at negative 2, negative 5. Right there. Maximum at 0, 0. So I know that's a minimum. It's a maximum. Do that just to remind me. Intercepts at negative 3, 0, and 3, 0. So these are relative mins and maximums. And then behavior, as we go to the right, we go up. So I know that this is going to be going up. So knowing that this is a maximum, this is going to come down somehow and go up. This will come down, and this will go up, and it's even. So because this is going up, I know this side's going up as well. Right, remember that positive, even, tells us, and behavior is positive, infinity, negative, even, and behavior is negative, negative. Okay? Yeah. Alright, 7 and 8. Last two. So h of x is a function with intercepts at negative 3, 0, 1, 0, and 0, negative 3, y-intercept. Minimum at negative 1, negative 4, and maximums at negative 3, 0, so maximum, minimum, and 1, 0, maximum. And behavior, as we go to the right, we go down, so as we go to the right, we go down. So when you're dealing with end behavior, usually the trick is that last x-intercept on that side, so on the right or the left, from there, that's when you apply the end behavior. And as we go to negative infinity, we also go down, so that's going down. So now it's just kind of connect the dots to make it look like that. Okay, that would be that negative even. Last one, number 8. There we go, much better. Okay, j of x is a function with intercepts at negative 5, 0, negative 2, 0, 0, 0, 2, 0, and 4, 0. So quite a few. Probably going to be some, a lot of this going on. And maximums at negative 4, 38, and 1, 5. And negative 4, 38. Well, 38 is going to be clear up there, isn't it? So alright, hold on. We're going to have to let's see, this is 10, so really we're going to have to go clear down here. Yeah, that'll work. So we had negative 5, 0, negative 2, let's move this down closer to us. There we go. Negative 2, 0, 0, 0, 2, 0, and 4, 0. And then maximums at 1, 5. And negative 438. So that's negative 4 and 38. So like clear up there, we'll say. And minimums at negative 1, negative 6. So minimum, maximum, and 3, negative 12. So that's negative 10, 11, 12, right down there. And end behavior, as we approach to the right, we go up. So this is our last x-intercept. So I know I'm going up. And as we go left, we go down. This is my leftmost intercept, so I'm going down from here. Probably a little steeper, right? Because I got to go clear up there. So then let's start with this right side. So we've got to go down, clear down here, and we can back up to here, and back down to here, hitting those x-intercepts. Then we got to go clear up, right? So we're going clear up, and I know my lines aren't very straight. Hit that guy, then clear back down until we get that. So there's our graph, minus that line. So that looks something like that, and there we go.